Hello everyone, welcome to the Digital Electronics lecture class. In this lecture, we will discuss the octal to decimal conversion and decimal to octal conversion. First, we will discuss the octal to decimal conversion. If we are given an octal number and we have to convert it into decimal, then we will multiply each digit in the octal number by the weight of its position, and then we will add all the product terms. Let us understand this with the help of an example. Suppose we have to convert 4057.06, which is an octal, to decimal. So we will multiply each digit of this octal number by the weight of its position. This 4 has 3 digits after it, so its positional weight is 8 to the power 3. This 0 has 2 digits after it, so the weight of the position of 0 is 8 to the power 2. Similarly, this 5 has only 1 digit after it, so its positional weight is 8 to the power 1. This 7 has no digits after it, so the positional weight of 7 is 8 to the power 0. Similarly, this 0 has a position weight of 8 to the power minus 1, and this 6 has a position weight of 8 to the power minus 2. So we have multiplied each digit of the octal number by the weight of its position, and then we have added all the product terms. After adding all these terms, the answer comes out to be 2095.0937. This is the value in decimal number system. So if we convert 4057.06 to decimal, the answer will come out to be 2095.0937. Now let us move on to the next type of conversion, that is the decimal to octal conversion. If we are given a mixed decimal number and we have to convert into mixed octal number, then we will convert the integer and the fraction parts separately. Let us understand this with the help of this example, in which we have to convert 378.93, which is a decimal number, to octal. Now this decimal number has integer part and fraction part. In this case, we will convert the integer part and the fraction parts separately to get the answer in octal. So first we will convert the integer part. So for converting the integer 378 to octal, we will divide the given number successively by 8, and we will write the remainders side by side. So when 378 is divided by 8, then the quotient comes out to be 47 and the remainder is 2. Similarly, this number is again divided by 8, then we get the quotient as 5 and the remainder is 7. Now when 5 is divided by 2, the quotient is 0 and the remainder is 5. Now we will read the remainders from bottom to top. Then we get the answer as 378 in decimal will be equal to 572 in octal. Now we will convert the fraction part. For converting the fraction part to octal, we will multiply the fraction by 8 and we will write the product in front of that term. Then we will keep the integer part as it is, and then we will multiply this fraction part by 8. So when 0.44 is multiplied by 8, we get 3.52. We will leave 3 as it is, and then in the next step we will again multiply this fraction 0.52 by 8, which will come out to be 4.16. Now we will leave 4 as it is, and then we will multiply this new fraction 0.16 by 8, which comes out to be 1.28. After 3 or 4 steps, we will stop the calculation and then we will read the integers from top to bottom. So when we read the integers value from top to bottom, the answer comes out to be 0.7341. So the value of the decimal fraction 0.93 when converted to octal comes out to be 0.7341. Now, combining both the integer and the fraction parts, the final answer comes out to be 572.7341. So the octal number 378.93 when converted to octal will come out to be 572.7341. In this way, we can convert any given decimal number to octal number. And similarly, if we are given an octal number, then we can convert it into decimal. Hope this conversion is clear to all of you.